I'm your Komali Mam. In this session, I'm going to teach you all excellent and simple tricks to solve molar conductivity and equivalent conductivity based questions very easily. See, when students are solving molar conductivity and equivalent conductivity, they feel difficulty like, converting molar conductivity based, they give data molar conductivity, they will ask you to find the equivalent conductivity of different ions. Or in equivalent conductivity itself, suppose if a salt is given and different type of anion or cation is present, then how to solve the questions. All these topics I am going to cover in today's session. Pay attention, many numericals I am going to teach you. By the end of this video, you feel very confident, and whenever you see these type of questions, very easily you will solve. Let's begin the session. What do you mean by this molar conductivity? What is the meaning of molar conductivity? Let us see the simple definition of this molar conductivity. The conductance of 1 mole of solution, 1 mole of an electrolyte. Suppose one solution is there, in that solution 1 mole of electrolyte is present. That 1 mole of an electrolyte, what conductivity it shows, that is called as, simply to say, molar conductivity. It is defined as the conducting power of all the ions produced by 1 mole of an electrolyte. 1 mole electrolyte, it produces ions. These ions conducts. That how much it conducts, we call it as molar conductivity. Molar conductivity. It was explained by Kohlrausch. Through Kohlrausch law, he explained. This topic is from electrochemistry chapter of class 12. See the definition. The molar conductivity of an electrolyte at infinite dilution. What is the meaning of this infinite dilution? Infinite dilution means you added more amount of water. More amount of water. How much amount of water you are adding is, you are adding in such a way the concentration is tending to almost zero, or you can say that ions are moving very freely. There is no force of attractions between the ions, and every ion is responsible for the conductivity. See, molar conductivity of an electrolyte at infinite dilution is at infinite dilution means you are adding more amount of the water. Then the sum of ionic conductivities of cations and anions. How many cations are there and how many anions are there? You have to multiply. How many cations? For example, 3 cations. 3 into each cation conductivity plus anions, 2 anions are there. 2 into each anion conductivity. So, what Kohlrausch says is, every ion contributes something to the total conductivity. Means, if suppose 5 ions are there, 5 ions are responsible for its conductivity. 1 mole of an electrolyte, if you dissolve in certain volume of a solution at infinite dilution, how much conductivity it shows? We call it as a molar conductivity. What is that? Molar conductivity. Now, let us see the formula. How to represent? See here, small tip I will tell you. Molar, this is lambda, right? This is lambda. This is lambda. You can write lambda like this, or lambda without this this part you can write like this, and down you write, students, m, top you write naught. This naught you can write as like this, or infinity like this also, which indicates that molar conductivity at infinite dilution, that is the meaning. Okay, now what are the ions which we are going to write for AXBY? How to dissociate? See now, what are the 2 ions are present? A is present, B is present. Write that both. After that, you are writing A, B. How many A's are there? X you write here. How many B's are there? Y B's are there. You write here. X A's are present, Y B's are present. Then what finished? First always cation will be, next always anion will be. First what is that? Cation and then anion. Over, right? Here important thing is What is the, how many Y ions, B ions are there? Y. That Y you write here. How many A ions are there? X, that X you write here. For example, NaCl is there. You know NaCl dissociates into Na plus and Cl minus, no problem. But Al2SO4 thrice is there. If you don't know how it breaks, suppose if you know, ma'am, Al2SO4 it breaks into 2 Al3 plus ions and 3 SO4 minus 2 ions. If you know that information, okay. But if you don't know how to write, see, limiting molar conductivity at infinite dilution of Na plus limiting molar conductivity at infinite dilution of Cl minus. Ma'am, how you are splitting this? See, NaCl. What are the ions present? NaCl. First you should write cation, next you should write anion. How many are there? Na, only one is there. How many Cls are there? Only one is there. Okay, how many Cls? And this number you should put as it's a charge. How many? This is only 1 Cl. It's a number Cl, only 1 Cl, so you should put as 1 charge. Again I repeat, BaCl2 is there. How to write BaCl2? See towards the screen. BaCl2. BaCl2. Limiting molar conductivity of BaCl2. Barium, Ba. And how many chlorines? 2 chlorines. First split. This is a cation, this is an anion. This number you put here. Here nothing is there, no, means 1, only 1 barium. So minus 1 is nothing but minus only. Which means that limiting molar conductivity of barium 2 plus, if you know that how it splits, then no problem, into Cl minus. But how many Cl minus? 2 Cl minus. That stoichiometry number we have to multiply here. Is it clear? See the next one. Limiting molar conductivity of Al2SO4 thrice. See how to break Al2SO4 thrice. Al2SO4 thrice. If you know it breaks into 2Al3 plus, ma'am, plus 3SO4 minus 2. This knowledge if you have, it's well. Ma'am, if I don't know, ma'am, how I should split. See, first write the ions. Aluminium, how many? 2 ions. Sulfate, how many ions are there? 3 ions are there. First always cation, next always anion. This number you put this charge, this number you put this charge. So which gives us 2Al3 plus ions and 3 SO4 minus 2 ions, sulfate ions. Is it clear? Now write it. Molar conductivity of aluminium ions plus molar conductivity of sulfate ions. But what is the stoichiometry number? Here 2 aluminiums, write 2 before. Here 3 sulfate ions, write 3 sulfate before. Clear? Now let us see. What is equivalent conductivity? What is the difference between both? See, identify the difference. When 1 gram equivalent, before molar conductivity 1 mole of an electrolyte, but in this case 1 gram equivalent of an electrolyte is dissolved in a solution. In previous case, molar conductivity case, in a solution we dissolve 1 mole of an electrolyte, but in this case we are going to dissolve 1 gram equivalent of an electrolyte we dissolve. Then whatever the conductivity is equal to all the ions which is produced, or we can say conductance due to all the ions present in that volume of solution. In that solution, 1 gram equivalent of that electrolyte shows how much conductivity. The equivalent conductivity of an electrolyte at infinite dilution. What do you mean by infinite dilution? We are adding more and more amount of solvent, so that that solution, so that we are taking more amount of the solution, so that there is no force of attraction between the each ion. Then ions are moving very freely and it is showing the conductivity. So, but here the difference between molar and equivalent is, equivalent case we have to take only the sum of the values of cation and anion only. So, the sum of the two values, one depending upon the cation, other depending upon the anion. That's it. See, equivalent conductivity is equal to, at infinite dilution, which is equal to equivalent conductivity at infinite dilution of cation plus, like this you should write, lambda EQ or E naught of cation plus lambda naught EQ of anion. Sum of the equivalent conductivities of cation plus anion. Here no need to multiply with the stoichiometric coefficient. Number of equivalents of cation plus number of equivalents of anion. That's it. For example, let's see. Equivalent conductivity of NaCl at infinite dilution. See, naught means what? Infinite dilution. Which is equal to, how to write? Equivalent conductivity of sum of ions Na plus equivalent conductivity of Cl minus. In this case, equivalent conductivity of barium 2 plus equivalent conductivity of Cl minus. How many Cl minuses are there? We no need to write. Is it clear? That is the first basic difference. Then equivalent conductivity of aluminium ions plus equivalent conductivity of sulfate ions. Which cation is present, which anion is present, that's it. Okay. First point is molar conductivity means sum of all cations and anions, and how many ions are there also we should multiply. Tip number 2, equivalent conductivity means we should not multiply with the number of ions. Okay, just which ions are present, that those equivalent conductivities we have to add, right? Next, if suppose there is a relation, between what is equivalent conductivity and molar conductivity is equal to equivalent conductivity at infinite dilution is equal to molar conductivity at infinite dilution divided by total charge. Total charge. This is the formula. This formula is important. We will see. We will see step by step. See students, see this question. How to solve this question? How to solve this question? Molar conductivity at infinite dilution for calcium chloride they were asking, and magnesium sulfate they were asking. How to solve? Calcium chloride, what is the formula? Molar conductivity at infinite dilution of CaCl2 is equal to molar conductivity of calcium ion plus 2 into molar conductivity of Cl minus ions. That's it. Calcium ion value is how much is given? 119 plus 2 into Cl minus how much is given? 76.3. 76.3. So 119 plus how much? 2 3s are 6. 2 6 are 12, 1, 2 7s are 14, 1, 15. Then we'll be getting 119, add 6, 11, 7, 271.6. Write the units. Simon centimeter square mole inverse. Clear? Next, same way, try for magnesium sulfate. Try for magnesium sulfate. What is the magnesium sulfate value? Come on, tell me. Magnesium sulfate, how to find? Magnesium sulfate. Try please. Magnesium sulfate. Molar conductivity of magnesium sulfate is equal to what, students? What? Molar conductivity of at infinite dilution of magnesium ion plus molar conductivity at infinite dilution of sulfate ion. What is the magnesium ion value? 106 plus what is the sulfate ion value? 160. 160. So upon adding 266 Simon centimeter square mole inverse. So here any difficulty? No difficulty. Just how many cations are there, how many anions are there, to take sum of all. And how many ions are there, just multiply that number. Okay. See the next question. Limiting molar conductivity or molar conductivity at infinite dilution for NaCl, HCl, sodium acetate are given. 3 values are given. They are asking for HAC. Acetic acid they were asking. What is the technique here? Simple trick I will tell you to write this reaction. See all of you. HAC. What is they have given? HAC. Write HAC here. Okay. What is there we want? We want H first. H is there. In this 3, where is H? H. Second one. Here H. H is there. HCl. Okay. Plus. First you write or second? Anything. Next AC is there. Where AC in this 3 data? Third one. NaAC. Here AC is there. We want AC. We want H. But we don't want Na and we don't want Cl. So, NaCl we don't want. Which you don't want? Right product side. Which you don't want? Right product side. Is it clear? Now, limiting molar conductivity of what? HAC, which is equal to the sum of these two minus of this. Reactants minus, see, limiting molar conductivity of NaAC plus limiting molar conductivity of HCl minus limiting molar conductivity of NaCl. Ma'am, why are you doing minus? If it goes outside, minus. Because sum of this and this you want. You want this H and this AC. You don't want Cl and Na. That's why you are subtracting. Okay. Now, NaAC value how much? Third one, 91 plus HCl is second one, 425.9 minus NaCl limiting molar conductivity. How much? NaCl is first one, 126.4. 126.4. So add these two, 425.9 plus 91. 516.9 minus 126.4. How much? 11 minus 2 is 9. 4 minus 1 is 3. 390.5. What are the units, students? Tell me. Simon centimeter square mole inverse. Easy. Any difficulty up to here? No difficulty, no? See, reaction how to write? Whatever you want, you write that in product. For example, see this question. They are asking molar conductivity at infinite dilution. So don't worry, I don't know the balanced equation. I don't know what are reactants, what are products. No need all such a thing. Simple trick is write the product, my dear students. What they were asking. NH4OH they are asking. So just write that NH4OH on your product side. Okay. Next, you want first NH4. In these 3 data, where NH4 is there? NH4 where it is present? Here it is present. So first take NH4Cl plus. Next NH4 is over. Next ion is OH. Where is OH? Here. BaOH twice. So you want NH4, you want OH. What you don't want? Barium and chlorine you don't want. So barium and chlorine you don't, which you don't want, you write product side. That's it. Now reaction is balanced or not. You see, previous case is already balanced. That's why I did not check. But now check it. Here 2 chlorines, if you observe 2 chlorines are there, but here only 1 chlorine. So put 2 here. 2 ammonias came, so 2 I'll keep. 2 hydroxides are there, 2 ones are 2. So here 2 hydroxides is just balanced reaction. Now, how to solve these type of question? We want this one they were asking. Okay. Now, molar conductivity of NH4OH. How many moles? 2 moles are there in this reaction, which is equal to, write it. This is 2 moles, is there, which is equal to 2 into molar conductivity at infinite dilution of NH4Cl plus molar conductivity at infinite dilution of barium hydroxide minus, if it barium chloride that side it go, minus it will become BaCl2. Now write the values. This value how much? Ammonium chloride 120. If this 2 comes this side, it will divide, right? If this 2 comes entire, see how I am writing. The same reaction, next step I should write, but I don't have space, so I am writing here only. This 2, I am moving to my right hand side. Here, 2. Then 2, this 2 will be cancelled. Here 2 will be left, here 2 will be left. So the value will be, check here, molar conductivity of NH4Cl plus molar conductivity at infinite dilution of barium hydroxide divided by 2 minus molar conductivity at infinite dilution of BaCl2 divided by 2. Okay, next, molar conductivity at infinite dilution of NH4Cl, how much is given? Directly substitute that. Easy na? Easy. Divided by 2 you do, minus BaCl2 is, BaOH twice is 450. 450. How much? 457.6 by 2 minus BaCl2 is how much, students? 240.6 by 2. Then 129.8 plus 2 2s are 4, 2 2s are 4, 2 8s are 16, around 228. Okay, 228 plus minus 2 1s are 2 120s are around. So roughly, then add that 129.8 plus 228, 357.8 minus 120. How much? 8, 7, 3, 2. 230, 237.8. What are the units? Ohm inverse or Simon? Centimeter square, mole inverse. Previously we have written mole, Simon or ohm inverse. Whatever the given units in the question, take the same units. Clear? Clear? Next one. Molar conductivities of BaCl2, H2SO4, HCl is given. They were asking barium sulfate. Will you try this question? Will you try? Pause the video and try the question. Barium sulfate, they were asking students. If they are asking barium sulfate, what are the answer present? Barium. So take barium chloride plus. Next one is sulfate. Where sulfate is present? H2SO4. Take it. Then plus, we want only barium, we want only sulfate. We don't want H2, we don't want to Cl2. So where we don't want HCl, which you don't want, write this side. But here 2 chlorines are there, here only 1 chlorine, put a 2. And remaining everything is balanced or not, check it out, everything is balanced. So the barium chloride value is given as X. H2SO4 is given as what? X2. And HCl is given as X3. Then we want barium sulfate. Molar conductivity at infinite dilution of barium sulfate is equal to, that is X1. Next one, this is X1 plus, next is X2. If it goes that side, 2x minus 2x3. X1 plus X2 minus 2x3. Where is that? Molar conductivities of barium chloride, H2SO4, HCl at infinite dilutions are given. Okay, they were asking equivalent conductivity, not molar conductivity. This is the formula of what we found? Molar conductivity. But in question, what they are asking? Equivalent conductivity. What is the relation between both, students? Tell me. Equivalent conductivity of barium sulfate is equal to molar conductivity at infinite dilution by charge. What is the charge? Either cation charge or anion charge. Barium sulfate, how we dissociate? Ba2 plus SO4 minus 2. How we dissociate? Ba2 plus, just now I explained how the dissociation will be. Take the charge, either cation or anion charge. 2. 2 is the charge. So 2. Then this X1 plus X2 minus 2x3 divided by 2. Any option? Yes, option number 4 is the correct answer. Clear? Clear? See the next question. Molar conductivities at infinite dilution of these 3 is given. They are asking for acetic acid. This is test yourself question, homework for you. Test yourself. Try this question and find it out whether your answer is correct or not. I'll explain you in next video. Next one. The following limiting molar conductivities is given. For this you have to find, test yourself. Test yourself question. Take screenshot and try and let me know what is the correct answer in the comment section, and let me know how is the video. Okay, see, this is the most logical model. Okay, this model, if you are done with this model, that's it. This is the final model. If you are done with this model, any question based on the molar conductivity and equivalent conductivity based on infinite dilution, you will do it. Okay, let's see what is the logic here. The ionic equivalent conductivities of oxalate ion, potassium ion and sodium ions are X, Y and Z Simon centimeter square equivalent inverse respectively. Calculate equivalent conductivity at infinite dilution of NaCOO-COOK. If suppose, if any example like BaCl2, one barium ion, two chloride ions, both the anions are of same type, then no problem. Till now how you solved the numerical, same way you should do. But if any salt which is given in the question is having either two cations or two anions, see in this case one sodium, one potassium. Okay, so two different cations are present, then you should not solve the question like how you have done till now. Different manner you have to solve. Let us see how. See now, equivalent conductivity at infinite dilution of COO-Na, COO-K is equal to, actually how it dissociate, actually COO, COO-Na, COO-K. How it dissociate is COO minus, CO minus, nothing but C2O4 minus 2. It breaks into COO minus, COO minus, nothing but C2O4 minus 1, total minus 2 is the charge. And here Na plus and K plus. These are the ions which we get after dissociation. So, equivalent conductivities is equal to sum of this plus this plus this. Correct? Sum of this plus this plus this. But see here, how to find the number of equivalents. Equivalents. This is only for when more than two different cations or two different anions are present in the salt, then only you should do in this format. Otherwise, till before what you have done, same way. Number of equivalents of ions is equal to charge on ion by total charge. Total charge. What is this formula, ma'am? Let us see. What is this formula? Let us see. Number of equivalents of, how many equivalents of oxalate? You know, what is the charge on this oxalate? Minus 2. What is the total charge of this anions? Only one oxalate ion is there, so total charge also minus 2. So, number of equivalents is 1. One equivalent of oxalate ion is there. One equivalent. Next, number of equivalents of Na plus. How much? Number of equivalents of, what is the total charge on this cation? 1. What is the total charge on this cation? 1. What is the total positive charges? Plus 2. So, half is the half equivalents of Na plus. Number of, again repeating, number of equivalents of potassium ions. What is the formula? Charge on ion. What is the charge? 1. Total positive ions charge. Here plus 1, here plus 1, 2. Then half equivalents. What is the meaning is, this oxalate ion, if suppose if it is losing one equivalence of electrons, see what happens actually, anions moves towards the anode, where the oxidation takes place, loss of electrons, those electrons moves towards the cathode, where cathode takes the electrons, reduction takes place. This is right. See here, this anion lose 1 mole of electrons. That 1 equivalent of electrons was accepted by half equivalents by Na plus, half equivalents of K plus. So see the formula. Equivalent conductivity at infinite dilution of this salt is equal to number of equivalents of C2O4 minus 2, but it is one equivalent, but that equivalent was gained by half equivalence of which one? This is half equivalence of K plus, half equivalence of K plus half equivalence of which one? Na plus. Na plus value is how much? Number of equivalents of Na plus is Z. So this one half equivalents and each one conductivity is Z. And this half equivalents and each one conductivity of K plus is how much? Y. And this is how much? This is oxalate ion is X. So our answer will be X plus Y by 2 plus Z by 2. Z by 2 is the answer. What is the answer, students? Tell me. X plus Y by 2 plus Z by 2 is the answer. Okay. So this is the typical numerical. What I have done? First I have calculated number of equivalents. How many equivalents? Total charge of that ion by total charge on the cations or anions. If you take K plus 1 plus positive charge divided by total cations positive charge is 2. So 1 by 2. Like that each equivalents you have to calculate, and that equivalence how much is given in the question? You have to multiply half into the conductivity it shows is X suppose, then multiply with that X. In such a way you have to do only when two different cations or two different anions present. See the next question, you get more clarity. See this question. Ionic molar conductivities of oxalate ion, K plus ion and Na plus ions are given, and they were asking calculate molar conductivity at infinite dilution and equivalent conductivity at infinite dilution. When they ask you, when they give molar conductivities, no need to do anything, directly you can calculate it. Molar conductivities of NaCOOK. If they ask, then molar conductivities of C2O4 minus 2 plus molar conductivity of Na plus at infinite dilution plus molar conductivity of K plus at infinite dilution. Then what you will be getting, students? This is X dash plus Na plus is how much? Na plus is last one. Z dash plus K plus is which one? K plus is Y dash. This is molar conductivity at infinite dilution. From this, equivalent conductivity is equal to what is the formula? Molar conductivity by total charge. What is the total charge here? Here molar conductivity at infinite dilution is X star plus Z star plus Y dash, X dash plus Y dash plus Z dash by total charge. If it breaks, we will get CO4 minus 2 K plus Na plus. Total charge is plus 1 plus 2 or minus 2. Anything, any one charge you have to take. So either plus 2 or minus 2. So mod we take as for the charge. Okay. So 2. Then in previous case also directly I actually substitute minus 2 divided by minus 2. Even you can directly substitute without that negative. Then this is your answer. Done? Next, last question. Okay, last question. Most interesting question. See this question. The ionic equivalent conductivities of K plus, Al3 plus and sulfate ions are X, Y and Z respectively. Calculate limiting molar conductivity at infinite dilution and limiting equivalent conductivity for K2SO4, Al2SO4 thrice, potash alum they are asking. Okay, they have given us equivalent conductivities in the question, students. Then you should not do like all the sum. Why? Because K2SO4 Al2SO4 thrice 24H2O. Okay, forget about these water molecules. What are the ions which we get upon, what are the ions which we get? 2 potassium ions plus, here 3, there 1, total 4 sulfate ions plus 2 aluminium ions. These are the ions which are present. So, if you observe only one type of anion is present, okay. But how many types of cations are present? 2 types of cations are present. 2 potassium ions are present and 2 aluminium ions are present. So, in this case, how to find it out equivalent conductivities is, let us see. You have to find each number of equivalents. Number of equivalents is equal to, what is the formula? Charge on that ion by total charge. Let's say number of equivalents of potassium ion. What is the charge on this ion? Plus 1 into 2 plus 2 divided by total charge on the cations, 2 into plus 2. 2 into plus 3. Plus 3 is plus 6 and here plus 2. Total charge is plus 8. So 2 by 8 is 1 by 4. You can take here plus, instead of plus directly also you can solve. Okay, 1 by 4 is the number of equivalents of potassium ions. Next, number of equivalents of Al3 plus ions. What is the total charge on this Al3 plus? 2 into plus 3 plus 6. Total charge on the cations plus 2 plus 6 plus 8. Then it will be 2 3s are 2 4s are 3 by 4. So the number of equivalents of potassium ion is 1 by 4. The number of equivalents of aluminium 3 plus ion is 3 by 4. Now let's find it out. The number of equivalents of sulfate ions. Then what is this number of equivalents of sulfate ions? Here 4 into minus 2. This is minus 8 divided by, okay, 4 into minus 2 minus 8. This is charge on this anion. Okay, total charge of anions, only this anions are there. Okay, only sulfate anion is there, no other anions. That is also 8 to 4 to 4s are 8. Then it will be 1 equivalent, which means this anion is 1 equivalent of electrons it is losing that was gained by the cations. 1 equivalent of anion, electrons it is losing anion that was gained 1 by 4 equivalents of K plus ion gained and 3 by 4 equivalents of Al3 plus ions gained. Which means how to write it is equivalent conductivity at infinite dilution of potash alum is equal to K plus ions. Potassium ion, how many equivalents? Half equal, 1 by 4 equivalents. And each equivalent of potassium, its conductivity is how much? X. Plus, how many equivalents of aluminium? 3 by 4 into each aluminium ion equivalent's conductivity how much? 4. Y plus sulfate ions. Next ions are what? Potassium ions, aluminium are over sulfate ions. So sulfate ion how many equivalents? 1 equivalent into each ion conductivity. How much it shows? Sulfate ion is Z. So write Z. Then it will be X by 4 plus 3Y by 4 plus Z is the formula. Is it clear? I hope you understand the session. Any question after the session you can solve very easily. My name is Komali. I am your chemistry mentor. Thank you so much for watching this video. If you are watching for the first time, please subscribe to my channel, and if you like this video, hit on a like. Thank you so much. Bye all of you. See you again in next video. Have a great day.